Hey everyone, good morning, good afternoon, good evening, wherever you're joining from. I'm excited to be here with you at the GraphQL Summit. Today and tomorrow, you'll hear from community experts about what's new with the graph. But first, I'd like to take a moment to thank every one of you. The graph really is changing the world, and it starts with our community. 5 years ago, Apollo ran the first GraphQL Summit in a tiny event space here in San Francisco. Today, we're gathering online with thousands of you joining in from over 100 countries around the world. And that growth of the community and of GraphQL has only accelerated. For starters, GraphQL.js monthly downloads have tripled in the past 2 years. That's amazing. And while JavaScript will always have a special role to play in GraphQL because of its heritage in design and product engineering, it isn't just about JavaScript. There are now client and servers in almost every language thanks to you. We'd especially like to celebrate the GraphQL 2021 spec, released just a few weeks ago. It includes exciting new features like a standard spec for custom scalars and more flexible interfaces and directives. We're also excited to celebrate another milestone. This year, Apollo Client hit 12 million downloads per month. And to put that in context, that's about a quarter of React downloads. So we're talking about a meaningful fraction of all applications now built on a graph. And a growing number of developers are making the switch. In fact, from the State of JavaScript survey, we know that 87% of JavaScript developers want to learn GraphQL. And with over 44,000 GraphQL job posts on LinkedIn, the demand for skills has never been higher. That's why we built Apollo Odyssey, our new learning platform. We designed it to be a really fun experience. They're short, interactive courses that feature code challenges that cover the entire stack. You'll learn everything you need to build and run a graph, and when you do, you'll earn a certification that you can share with the world. If that sounds cool, check out the Odyssey workshop happening tomorrow here at the conference. The graph really is everywhere. Developers at nearly 40% of the Fortune 500 are choosing GraphQL. From web apps to mobile and digital devices, the graph powers some of the most popular apps in the world. You're using it multiple times a day. If you're shopping at Walmart.com, you're on the graph. If you're starting your next workout on Peloton, you're on the graph. If you're binge watching Netflix, you're on the graph. If you're selling your home on Zillow, you're on the... Hugh, I'm in the middle of a keynote. What's up?
Yeah, I know. That's why I'm calling. I just wanted to give you an update on the project with Microsoft. It just shipped. They completely rebuilt Microsoft Teams using React and Apollo, and it only took them 6 months. That means Apollo is now in Windows 11, and Teams 2.0 is going to have half the memory footprint. Really, really incredible stuff. The thing the team is the most excited about, though, is that Microsoft is going to be contributing back to Apollo and GraphQL.
Oh, that's awesome. Thanks for letting me know, Hugh. That's so cool. We welcome Microsoft. It's exciting to have them contributing back to GraphQL along with hundreds of other great companies and developers. Let's step back for a moment and ask ourselves the question, why are developers, startups, and Fortune 500 companies all adopting the graph? What's really going on? Certainly, GraphQL helps us go faster. It lets you say goodbye to all the old REST endpoints and backend for front-end code and intricate state management code that costs so much to build and keeps slowing you down. Graph lets you replace all that stuff with a schema, a universal API that lets you build new features and a richer, more engaging experience with far less work and in far less time. As you build your schema, what you're really doing is creating a virtual representation of all your data, services, and capabilities. That's the graph, a new layer in the stack whose value goes up as you add more and more to it. And there's a deeper benefit that comes when you adopt Graph, because it fundamentally transforms the way teams can work together. To see that, look at the backend side of the stack. The story of the last 10 years there has been about elastic computing, containers, orchestration, cloud native. In the old days, you needed dedicated servers and separate teams of experts for every new system. But now most any team can build a microservice in whatever language works best for them and deploy it side by side with others into a common environment with shared tools and capabilities. And on the front end, we have the same idea. React fundamentally was designed to allow multiple teams to work side by side on a common UI. Those same benefits of modularity and isolation are why it's been adopted so quickly and at such scale. And again, we see the rise of great tools like design systems that elevate what's possible. In both cases, what's going on here is composability, small, isolated modules that fit together in a principled way and that can be reused in new combinations as requirements change and new opportunities emerge. You've never had a composable API before. APIs aren't like that. You can't change another team's API any more than you could add some jQuery to someone else's page or install your daemon on another team's Unix machine. And so there was no reuse. Each new feature bottlenecked on a new API. But the graph is different. By its very nature, it's composable. 2 teams, 10 teams, even 100 teams can each own their slice of a single unified graph, with great tools for modeling, building, testing, integrating, and so on. So composing a graph can be as simple and delightful as importing a React component or spinning up a Docker container. That's why we built Federation, a declarative architecture for composing multiple graphs into one using tools instead of writing code. And by the way, composability works for teams of all sizes, not just huge companies. It's really about the way we structure our work, how we collaborate with each other, and how we can solve today's problems quickly while building a strong technical foundation for tomorrow. This change to how we write software together is really why I think the graph is so transformative. And all of you are at the center of it. Today is about that transformation and the things we're building to help you get there. Let's welcome Parul Shroff, Product Manager at Apollo. She's going to demo new tools you can use every day as you build, query, and share your graph.
Thanks, Matt, and hi, everyone. Our core mission here at Apollo has always been to make it super easy for you to build amazing apps on top of your graphs. With Apollo Client, we've made consuming data from your graphs as flexible as possible. And with our free tools in Apollo Studio, we help exploring your graphs and find the capabilities you need in order to innovate even faster. Today, I'm excited to share with you some new improvements that we have made in Apollo Studio that are completely free to use. For the purpose of this demo, let's use the public GitHub GraphQL API, since many of you are already familiar with it, so hopefully it will be easy to follow along. But this example can be applied to any graph that you are developing internally. Let's say I want to build an app, and using the public GitHub GraphQL API, I want to expose the start repository on this app. To find this information, I head over to Apollo Studio, the control plane for this graph. Now, for this example, we already published the GitHub GraphQL API in Apollo Studio. Right away, I can see the README page, a landing page for this graph. It's a great place to share example queries and help your developers get oriented. So here I can see the information that I need, including a description of what this graph is about and an example operation that I can run. Now let's take a look at Apollo Studio Explorer. We launched it about a year ago. It's a really great GraphQL IDE to help make exploring and querying your graph in Apollo Registry quick and easy. Okay, so let's click on this mini run button here. Straight away, I'm taken to Explorer with the sample operation loaded, just like that. Let's take a look at a few additional helpful functions. With the Command K shortcut, I can pop open the Spotlight search and find the field I need in any size schema. If I want to build my own query, I can open a new Explorer tab. Yes, you heard that right. Tabs was one of the most requested features for Explorer, and they are now live and ready to use. Okay, so in this new tab, we'll do another Spotlight search for the fields that I need. You can find and build a query even if you don't know where to look or know the query syntax. For the app that I'm building, I need start repositories for a user. So I search and select that, and then I click on some additional fields that I need. And there you go. The query is built for me. And you can have the power of Explorer and its amazing experience no matter where you're doing graph development. We recently introduced Explorer as the default IDE for Apollo Server 3, making it possible for you to use Explorer against your local endpoints. 60,000 developers are already using it, and they love it. Let's see what that looks like. Here in VS Code, I'm going to run npm start for Apollo Server. Then I open Sandbox that points to my local host. Let's make a quick change to my schema and refresh that. Swiping back to Sandbox, you can see that the schema is automatically updated with the change I just made. So there you go, it's delightfully quick and simple. But that is not it. We have made sure you can put Explorer anywhere you want to make it super easy for anyone to query and explore your graphs. You already know you can run operations against your production graphs in Apollo Studio Explorer. We just examined how you can use Explorer against your local GraphQL endpoints. And now I'm going to show you how you can embed Explorer on any web page, including your documentation site. So let's say we want to embed this GitHub graph that helps developers explore their repositories on the Apollo Docs page. We'll pop back into Explorer. I click on this meatball menu, and then I click on Embed this operation. There's a modal, and I can make some configuration changes. Let's say I want this dark themed, and I want to keep the docs panel closed by default. I grab the embed code. We want to add this to our documentation site, so I'm going to open up the Apollo Docs page. As you can see, it's pretty empty right now. So let me just paste the code I just copied into the docs site and save and restart. And there it is. Explorer is now embedded into the docs page, ready to use by developers looking to explore and query this GitHub graph. You can do it just as easily for any of your graphs. I'd like to mention one last thing. You probably already caught on here, but you can take any registered graphs in Apollo Studio and mark it as public. This lets anyone visit the generated public graph link, explore the schema, and query against that graph. That's what we have done here with the GitHub graph. We published it in Studio and we marked it as public. Try it out for yourself. Use the link on the screen or in the chat and visit the GitHub public graph. You don't have to log in. Check out the README and start exploring. Well, there's a lot more I didn't cover today, but if you're interested in learning more about our recent releases and watching some very cool demos, do check out the Secret to Successful Graph Onboarding presentation by Daniel Mann later today. Back to you, Matt.
That's awesome, Parul. How you use the graph is just part of the story. The other big thing is how you manage that graph, and in particular, how you manage changes. Deep Varma, CTO at Vero Bank, is no stranger to change. I sat to talk to him about how he is helping his developers scale and manage change.
So look, my job as the CTO of the company is to find the right tools and the architecture which empowers my developers to build the best product features, for the Varo Bank. And the team has decided very early on that they wanted to go towards graph. And, federation was a no barrier for us. And frankly speaking, it gives us all the advantages of a graph. And it really puts this development in the hands of the developers without building a system where it is choking one point that someone else in the organization is owning it. Now, the big benefits what we got out of the federation is the rapid iteration, right? So it allows us to change our graph much faster. We can publish our schemas multiple times in a day. We can merge our MRs within an hour. And that means, the team can ship features in matter of days rather than waiting for months, right? So giving you a specific example, if my legal team comes and says, I want to make some changes to these terms and conditions, we can easily go into that subgraph, we can make those changes, and we can deploy it without impacting any other team's work. And really, it made my team's life much better and simpler.
Deep and his team are enabled by the flexibility and accessibility of the graph. That helps them rapidly innovate. And I think that's a key point. Healthy graphs change a lot, and great change management enables that. So I'd like to introduce Mandy Wise, head of our solutions team here at Apollo. She's going to demo our new tools for teams that manage the graph.
Thanks, Matt. I'm Mandy Wise, and I lead the solutions architecture team at Apollo, and we help roll the graph for some of our biggest customers. Much of our work focuses on helping organizations launch and adopt change management best practices for the unified graph. And the Apollo Studio Schema Registry makes the productive evolution of these graphs possible. Let's talk about why. When you're scaling out your graph, and particularly if you're in a large organization, you may need to keep track of dozens of different subgraphs that compose your overall graph schema. When building distributed GraphQL architectures with Apollo Federation, independent teams can each manage a relevant slice of the graph's capabilities. But you still need to ensure that as teams actively evolve their type definitions, that these modifications won't cause breaking changes for other teams that rely on those types and fields, or the client applications that query the API. This is where Managed Federation really shines. The registry is the machinery that lets you securely manage your composed schema, as well as track changes to it over time. So it's a critical tool for both front-end and back-end engineers alike who consume and contribute to your graph. And to make this process more transparent for the team members who contribute these changes, we've recently released the new Launches dashboard in Apollo Studio, which is designed to support rapid schema evolution and make deployment progress more observable. Let's take a look at how that works. With Managed Federation, whenever you publish a change to a subgraph schema, Apollo Studio will start a workflow to compose your overall supergraph schema and check it against tracing data to make sure you won't break any existing client operations, and then dispatch this updated configuration to any applicable nodes and any configured webhooks. This automated process, which is called a launch, makes it much easier to deliver changes to federated graphs with confidence. However, for teams that frequently make schema changes, observing the progress of a particular launch and tracking down errors may be a challenge. The new Launches dashboard is designed to solve that problem. In this example, we'll see how a fictional bank called a Cefi Bank might debug and fix a failed launch using the new Launches dashboard in Apollo Studio. Okay, so we'll make a change to a Cefi Bank's customer info subgraph schema. We're going to update the user entity to use its email field as a key instead of the ID field. Because we're making a change to the user entity, we need to check that against the supergraph schema to make sure that this change won't break its overall composition, and also that it won't compromise any client operations currently run against the graph. After publishing our schema update using the Rover CLI, we can go back to Apollo Studio to check the launch status. And it looks like we have a failure here, so let's take a look at the errors. Since we changed the user key from ID to email in the customer info subgraph, this will in fact break composition where any other subgraphs reference or extend the user entity until they also update their user definition. So now that we know what's wrong, we can fix this in our other subgraphs. And just like before, when we update the user entity in these other subgraphs, we automate the schema publication process using the Rover CLI. And after we publish these changes, we can see here that we got the green light for our launch, and we can navigate over to the schema view in Apollo Studio and see the updated user entity and the newly composed SDL for our graph. So the new Launches dashboard gives better insight into deployments and helps provide teams with the confidence they need to rapidly iterate a federated graph. But change management goes beyond simply tracking a given team's schema updates and safely incorporating them into the graph. Sometimes your unified graph needs to support different use cases for different audiences. For example, your graph may be queried by a mobile app, but when a particular version of that app is packaged, it will count on the specific fields in the operations that it runs being available forever. So you may not want to expose your entire graph to these mobile clients where certain fields won't be supported for the entire life cycle of a given app version. It would instead be better if we could use the type definitions within the unified graph as the building blocks of a tailor-made schema to support this specific use case. But at the same time, it likely wouldn't be ideal for us to try to manually manage two slightly different variations of our unified graph, because we can easily imagine other use cases that would require only a subset of the unified graph to be exposed on a per-client basis. For instance, you may wish to expose a portion of your graph for public consumption, or you may offer a partner API. And if you work with many different kinds of partners, you may need to expose different subsets of the graph to them based on those specific business relationships. Or you may also wish to define fields in your graph that are meant for internal use only within your admin tools, because those fields backing data sources may not have the capacity to serve customer-facing traffic. So along with launches, we're excited to announce contracts. Contracts allow you to have the best of both worlds, where you can maintain a unified definition of your graph, but declaratively expose subsets of your type definitions as additional purpose-built variants of that graph. And these two features go hand in hand in Apollo Studio because teams can design their subgraph schemas to support various client use cases with contracts, while also validating those schemas as a part of an integrated build pipeline and regenerating affected schema contracts with each launch. So you can be very intentional about the promises you're making via these contracts, but also continue to evolve all of them simultaneously at the speed of product. Let's take a quick look now at how to set up a contract. If we start with our unified graph that's been federated across teams, we now want to restrict access to parts of that graph to hide potentially sensitive data for certain clients. For example, at a SEFI bank, if we're building a client app that will be used by loan officers to provide customer support, we may want to add fields to the graph that shouldn't be queryable via customer-facing applications. So we can do this declaratively with contracts by using the @tag directive to add metadata to subgraphs that will help Apollo Studio filter this internal representation of the schema. Starting here in VS Code, let's add the @tag directive to the mortgage application field on the root query type and then set its single name argument to internal. After deploying this update, let's jump over to Studio now, and we can create a contract that excludes this internal field from the customer-facing graph. And with a running instance of our graph that points to the variant of the graph schema that does not include internal fields, we'll see that we receive a validation error message if we try to query that field. And this is what we expect, because from this variant's perspective, that field doesn't exist. So in just a few easy steps, we can see that the mortgage application data can no longer be queried from any contract based on the unified graph that doesn't include fields that were tagged internal. And Matt, that's how Apollo is supporting change management of the graph, so you can continuously innovate your schema safely and securely at any scale.
Thanks, Mandy. Now let's talk about Apollo Federation. Federation has become really important to us here at Apollo. It's unlocked adoption of GraphQL at thousands of companies of all sizes because it solves the key challenge of how multiple teams can collaborate on a single unified graph. And we've been hard at work on what's next for Federation. Let me welcome Phil Prasic, Principal Product Manager at Apollo, to share what we've been working on.
Hey, thanks, Matt. It's been amazing to see the momentum building around Apollo Federation with over 1 million weekly downloads, 12,000 plus projects using Apollo Federation, and tons of community involvement and engagement. There's a thriving ecosystem around Apollo Federation, so you can federate subgraphs written in your favorite language or framework. Federation is really what enables the composability and modularity we're after as developers. In just a few steps, you can create a graph to power awesome app experiences that users are after. I'm joined here today by Stephen Spalding and Tejas Shikare from Netflix. Netflix and Apollo have been working closely together on Federation for some time. And today, I'd like to invite them to share their journey with Apollo Federation with us, including the wins, the challenges, and where Federation's headed next. Welcome.
Thank you, Phil.
Thanks, Phil. It's great to be here.
So can you walk us through your journey that led to Federation and how Netflix got started with the graph?
Sure, yeah. Well, as many people do in the industry, we started our GraphQL journey with a monolithic GraphQL server about 3 years ago on the Studio ecosystem business. And basically, to keep it growing, we kept adding a lot of types and fields to that. And while we were doing that, we encountered all kinds of friction, and it was starting to show up as we scaled and evolved the graph. So my team, who owned the GraphQL server, was spending a lot of time on handling operational burden, talking to developers who were reporting issues, etc. And then in addition, every new feature had to go through 2 implementation cycles. So first, it had to be implemented in the backend, and then it had to be implemented in the GraphQL server before the client can implement it. And this really added to the feature development time. However, overall, we were pretty happy with the GraphQL API and the value it provided to the clients, but these bottlenecks really started to slow us down. So we needed something that would, 1, let us define the graph incrementally, and 2, distribute the implementation of the graph across multiple teams. And that's how we got to Federation.
Awesome. So you're definitely not alone in those challenges. We hear that story a lot. But as you realize the monolith wouldn't scale, how did Netflix end up landing on Apollo Federation?
Well, what we were looking for is quite simple. we wanted a way to declaratively define the portions of our graph such that they could be composed together without bespoke stitching logic in the gateway. And Apollo's federation spec delivers this. So then the other big factor was community. There's an African proverb, if you want to go fast, go alone. If you want to go far, go together. And if Netflix went off and did our own thing, we could do it just the way we want it, but we diverge from the GraphQL community. And that community is a big reason that we decided to bet on GraphQL in the first place. So now the federation spec was new at the time, but we'd seen Apollo be a key innovator in the GraphQL space for several years. And that gave us confidence that this could become something that is embraced by the GraphQL community.
Yeah, I totally do agree with that. Community is so important, and we're grateful to have such a vibrant community around the project. It really does take a village. So, if you've been using Apollo Federation for a while now, what are some of the key benefits you've seen?
Yeah, sure. We're passing on 2-year mark on our Graph Federation journey. And, I can rave about the benefits all day, but let me zoom in on a couple of them. So what does Federation really give you? I think if you think about it, it allows your API and take a big API and break it into chunks to match your organizational structure or way your domains are structured, and then essentially now you can take these different chunks and develop them independently by the teams that own them, and then Federation magically ties all of these chunks together to form a unified API for the clients. So my team initially owned the entire GraphQL monolith and the underlying resolvers and the schema. But with Federation, we were really able to delegate these to the appropriate domain teams. And this was huge. With this, we had a unified GraphQL API and consistent team boundaries for backend developers and app developers. App developers were able to focus on building better apps with the unified API model at their fingertips. And backend teams were now able to deliver changes in an autonomous fashion to the API and the backend code, and without as much cross-team collaboration and coordination. They were also able to onboard more quickly with all the excellent docs and training that Apollo has created. And then another big win for us was also we started to have better schema health. So instead of my team, which previously owned the entire GraphQL API, designing and maintaining the schema for all the domains in Netflix, we have now domain experts weighing in on the critical schema decisions. And this has been a huge win. So, Phil, I can talk about this all day, but back to you.
Thanks, Tejas. Yeah, it really sounds like Apollo Federation's helped the teams deliver and scale faster and in a more autonomous fashion, but in a way that was sustainable for everybody. So what are some of the challenges you're facing with Federation today?
Yeah, well, Federation today is very powerful and it solves a lot of problems, but we've wondered if it couldn't be made a bit simpler and yet at the same time become more flexible. In particular, if we could have a simpler GraphQL experience for new team members, this would really help with onboarding. If you can get started in the graph with a minimum set of new concepts and directives, and then these other features are available for the advanced use cases once you get there. So then a couple other areas that we thought it could stand to be improved was the type ownership model in composition is such that when you have a type defined in one service, then it has to be extended in other services. And so that initial service kind of de facto owns the type. And this can make it challenging when you want to move functionality between services. And that's the case we were in when we had a monolithic graph implementation that we wanted to move out into other services. And so then a third area of friction in the initial federation model is around shared types. We call these value types that are shared between subgraphs. And in the composition model, these have to be defined identically amongst subgraphs. And so that is a problem when you want to then evolve these shared types. And being able to evolve your API is one of the big benefits of GraphQL, and we want to be able to keep that. And so this is one of the areas that we thought that, can we make this a little bit more flexible?
Yeah, totally. That definitely mirrors what we've been hearing in the community, to make federation simpler and more approachable, but also more powerful for advanced use cases, which is why we're excited to jointly announce an evolutionary step forward that provides a simpler, more approachable way to build, manage, and scale your unified graph called Federation 2. Federation 2 is simpler and more approachable for new teams with a more natural GraphQL experience, first-class support for interfaces, and everything you expect from GraphQL. It supports smaller incremental changes to enable you to ship faster with support for shared value types, type merging, and reduce cross-team delivery coordination to scale faster. It enables a stronger source of truth with greater precision and control, but also allows you to fluidly evolve your graph to migrate fields and denormalize data to increase performance. It also provides a stronger safety net with enhanced build time validation and linter hints that can feed higher level policy and governance for design guardrails and best practices. This is all made possible by a clean sheet implementation of the core composition and query planning engine at the heart of Federation. And it's also backwards compatible with Federation 1, so you can opt in and migrate at your own pace. Here we can see the more native GraphQL experience that simplifies common things like extending a type or denormalizing a field for better performance without the use of special directives. Federation 2 has first-class support for interfaces, enum lifecycle, and everything you expect from GraphQL. Federation 2 supports shared value types and type merging, so each subgraph can define the subset of fields it cares about, and the composed supergraph schema will have a single unified type. This new shared ownership model enables a more incremental and flexible delivery of graph changes and more modular distribution of the graph implementation across multiple teams. Federation 2 also lets you assert a stronger source of truth with greater precision and control. And you can look at a single subgraph and see if it's the authoritative owner for a given field without having to understand the entire graph. We also have more powerful directives that simplify advanced use cases like migrating fields across subgraphs with no downtime to reduce cross-team delivery coordination. Federation 2 has composition hints that you can see as you type in Apollo Workbench to provide better visibility into how schema definitions influence query planning and performance of your graph. And we have deeper validation with better error messages and enhanced safety with governance to ensure design guardrails and best practices are in place for your graph so that you can move safely with confidence. So there's a lot more to cover here. And as I mentioned before, Federation 2 will be backwards compatible with Federation 1. So be sure to check out our talk on the future of Apollo Federation, where we'll walk through a live demo and dive into the details of what's coming next. We're early on in the process and would love your feedback. So check out the blog post on Federation 2, try out the alpha release, and let us know what you think on community.apollographql.com. Back to you, Matt.
Thanks, Phil. We're excited about the roadmap for Federation 2 and can't wait to hear your feedback. Thanks to Federation, we're seeing more and more companies on the graph with more and more traffic, and that's going really well. So as we look ahead, we're going to need even more from the infrastructure that powers the graph. The demands on reliability, on scalability, on security will only continue to increase. Graph infrastructure will need to run in a wide variety of environments, from the core of the data center to the very edge of the network, from massive machines down to the lightest weight serverless functions. Graph infrastructure is going to need to be more and more like network infrastructure. Plug and play, reliable, purpose-built machinery that's always on, that you never need to think about. Kind of like an internet router. So you can focus on what's in your graph, not the details of how it all works on the inside. At Apollo, we've been thinking a lot about this. And I have one more thing to share with you. Today, I'm really excited to introduce the Apollo router. It's our next generation Federation runtime, written in Rust and packaged as a standalone binary. We call it a router because it's like a network router. It accepts incoming traffic, plans queries, routes requests across services, and assembles the result. And as your graph grows, it creates a fabric that connects all your subgraphs, your contracts, and your clients together. The Apollo router is secure, lightweight, and easy to deploy into any environment. It has a well-defined extensibility model for adding additional functionality. And just like a networking router, performance is absolutely critical. It has to be fast. And the Apollo router is wicked fast.
Matt, I've just run one of our benchmarks and it shows the Apollo router adds only low single-digit millisecond P95 latency to the request pipeline. And that's running at over 12,000 requests per second on a single machine. That single-digit millisecond overhead is the magic number that makes federation an easy choice for teams at all scales. The router is a lot more efficient. In that same benchmark, we're able to get more than 8 times the total throughput on a maxed out 8-core machine with a single multi-threaded Rust router than we could with a whole bunch of JavaScript gateways. These are early results and they're already painting an exciting picture. It's so cool to have the fine-grained control that we get working with a language like Rust. Our first alpha is out today and we look forward to you trying it out.
And let me say a word about Rust. At Apollo, we've been using Rust for more of our tools, like Rover, and now the router, and we really like what we've found. It's the right tool for the job, and it's a community that we've really enjoyed getting to know better. So we're all in, and we're making a big commitment to it. Last month, we announced Apollo RS, a collection of open source, spec-compliant tooling for working with GraphQL and Rust. We're using it in the router, and we encourage anyone interested to take advantage of it in your projects. And we're just getting started. We think Rust and GraphQL go really well together. We're excited to have our Graph community grow closer to Rust, and we're looking forward to making many more contributions in both. And that's our North Star at Apollo. We're about building great tools and open technology that empowers application developers to do amazing things. It's what we do and why we put on Summit for all of you. This Summit is all about your learning and success. We've got some great speakers lined up over the next 2 days. There's sessions, panels, and workshops that we hope will inspire you and your teams. Enjoy the rest of your GraphQL Summit.